Today we'll be talking about material balance. Yes, material balance is applicable to chemical engineering, petroleum engineering, environmental science. So today we're going to understand the concept behind material balance, what are the principles that in which material balance are being guided. Material balance was gotten from the concept of conservation law of mass, and conservation law of mass says that matter can neither be created nor be destroyed, but it can be changed from one form to another. Cannot be destroyed, cannot be created, and convert from one form to another. Now, for conservation law, why is mass conserved? The total mass remains constant over time. Total mass in a system remains constant over time, regardless of the situation, whether physical or chemical changes may occur. So that's why mass can be conserved, because it remains constant over time. It remains constant over time. Conservation law of masses applies from the smallest subatomic particles to the entire universe. It is applicable to the smallest subatomic particles to the entire universe, regardless of how small it is, how tiny it is. Conservation law is applicable. Material balance is guided by a general equation, yes, which is displayed here, so this is the general material balance equation. Accumulation in the system is equal to the amount in the system when T is T2. We can call this the final. That is the final condition of a system minus the initial. That is when in condition minus the initial condition of that system. What it means that the final condition minus T1, what happens to the system, added was something removed, what was going in, that is the initial condition. And then the final condition is what happened after a particular time have taken place, after a particular interval, after a particular time. That is what final condition is, and which is also equal to system. Input to the system minus the output from the system plus generation in the system minus consumption. So this is the general material balance equation. This is the general material balance equation. This is the equation you'll be using when solving multiple problems that have to do with material balance. Material balance can be of two forms: material balance with reaction and material balance with no reaction. Yes, material balance can be of two forms, with reaction and with no reaction. So when dealing with material balance with chemical reaction, this is equals to the input to the system plus generation minus consumption. Chemical reaction is expected for something to be generated, for compound gases, something to be generated, something to be consumed, and something also going in and also something going out. So that's the concept of material balance with chemical reaction. But for material balance with no reaction, it has to, there is no generation. Generation is equal to 0. Consumption, saying that accumulation is equal to input minus output. This is for material balance with no reaction. Accumulation is equal to input minus output. Input minus output. There is no generation and there is nothing being consumed. So this is the concept behind material balance. And material balance is applicable to the conservation of total masses, mass of a component, moles of a component, mass or moles of atomic species. It is only applicable to total masses. We have to express them in masses. Why? Because we initially stated that total masses remains constant regardless of the physical or chemical changes that take place within the system. So it's best to express it in masses or in moles or in mass or moles of atomic species. So this is very, very important. We hardly get to see it being expressed in volume. Why? Volume cannot be conserved in all cases. Not in all cases. Sometimes you get to see it being conserved, but in specific situations. It answers the question, why is volume not conserved? Why is volume not conserve? So this answers the question because different materials tend to have different densities. Density is one of the factors why volume cannot be conserved, as well as it's not constant over time. When physical or chemical activities takes place, the volume might change. So the volume might change. Just like a compressor, when you tend to increase or decrease the pressure, increase the pressure, the volume reduces. So these are the kind of factors we consider why volume cannot be conserved. You hardly get to see you talking about volume balance. No volume balance, it's just material balance. And it's best to express it in mass or moles. So we get to see multiple examples that has to do with material balance. Yes, material balance. Yeah. So material balance is very interesting. It's applicable in chemical engineering, in petroleum engineering, environmental science, even chemistry, industrial chemistry, though they also carry out material balance. So understanding the concept of material balance is very important whenever you want to carry out in a production firm, for example, or in an industry producing a particular material. It's expected to know what is going in and what is expected to come out. So this is the reason why material balance is very important. So it's very important to understand this concept, and when you get to see problems in the real world, you can be able to attempt it, understand the principle backing material balance, and how to use the general material balance to solve multiple problems. In my next video, I'm going to solve multiple examples, give more illustration about material balance, and thank you for watching. Hope you understand the concept behind material balance. Yeah, stay blessed and God bless.